Alrighty, today we're going to be talking about capacitance in AC circuits. So in the previous chapter we talked about how a capacitor is made up of two metal plates separated by an insulating material called the dielectric. Since there is no complete circuit between the plates, current cannot flow through the capacitor. The only time current can flow is when the capacitor is either being charged or discharged. Capacitors and AC circuits. When a capacitor is connected to an AC circuit, current appears to flow through the capacitor. Why would that be? Because current in an AC circuit continuously changes direction and polarity. Capacitive reactance. As a capacitor is charged, an impressed voltage is developed across its plates as an electrostatic charge is built up. And if you remember in the last video, what do we say electrostatic means? That means stationary. There's no moving parts. It's just stationary. Impressed voltage is the voltage provided by the electrostatic charge. The impressed voltage opposes the applied voltage and limits the flow of current in the circuit. This counter voltage is called capacitive reactance, and it's going to be measured in ohms. So here is the formula for capacitive reactance. The XC stands for capacitive reactance. Pi is just 3.14. F is frequency measured in hertz. And C is capacitance measured in farads. So let's work out an example of one of those problems. So if we had a 35 microfarad capacitor, and is connected to a 120 volt 60 hertz line, how much current? So we're looking for amps, right? So the first thing we would do is we need to find the capacitive reactance. So what is our capacitive reactance formula? It is XC equals 1 over 2 pi FC. So we know we're going to do capacitive reactance equals 1 over 2 times 3.14 times, what is the frequency of this? It's going to be 60 hertz. So times 60. And then we're going to say times 35, because that is microfarads. I didn't put that right there, sorry. Okay. So your capacitive reactance is going to equal 75.788 ohms, because we say capacitive reactance is measured in ohms, right? So now that we have our ohms, we can just simply do Ohm's law. So this one would equal, if we're looking for current, is going to equal our voltage, which is 120, right, up here, divided by our resistance, which is measured in ohms. So our current is going to equal 1.583 amps. So it's as simple as following this formula until you can put it into Ohm's law. Here is the capacitance formula. So if your capacitive reactance is known, the capacitance can be found with this formula. So it's just the exact opposite of the capacitive reactance formula, depending on which one you know. But you always have to find your capacitive reactance first. So this is going to be the formula if you're looking for just capacitance. So we're going to do another example. So if a capacitor is connected into a 480 volt 60 hertz circuit, and you have 2.6 amps what is the capacitance? So we're looking for capacitance, right? So we already know that capacitive reactance equals ohms, right? So we know XC is measured in ohms, right? So we already know ohms. Or we don't know ohms, we know current and we know voltage. So all we have to do is say XC equals E over I, and our I and E is given. So we can say XE equals, our voltage is 480 divided by 2.6 amps. And that is going to give us 184 ohms. Well, that's not a good ohm sign, is it? So that is our capacitive reactance. Now we can use our capacitance formula that we just seen. So our capacitance formula, just as a refresher, is 1, 2 pi, frequency, and then capacitive reactance. So if we do that, we're going to have C equals 1 over 2 times 3.14 times 60 hertz, because that was up here, and times whatever we got down here, which is 184.615 ohms. And that is going to give us 14.368 microfarads. Alright. I know it looks confusing, but if you just use those formulas, you're not going to go wrong with finding capacitance. Just always remember you're going to have to find your capacitive reactance before you can find your capacitance. The impressed voltage is 180 degrees out of phase with applied voltage. A capacitive circuit has no true power. The power required to charge the capacitor is returned to the circuit when the capacitor discharges. So as we know, the power value for a capacitor is reactive power, and that's going to be measured in VARs, and that's just like an inductor. So inductive VARs and capacitive VARs are 180 degrees out of phase with each other. In a pure capacitive circuit, the voltage and current are 90 degrees out of phase with each other. Capacitor voltage ratings. The voltage rating of a capacitor is actually the voltage rating of the dielectric. Voltage rating is extremely important concerning the life of the capacitor, and it should never be exceeded. Effects of frequency in capacitive circuits. One of the factors that determines the capacitive reactance is the frequency. Capacitive reactance is inversely proportional to frequency. As frequency increases, the capacitive reactance decreases. So let me go out here and make another blank page so we can just do a summary. Alright, so let's do a summary just to refresh our memory of what we've talked about today. So, when a capacitor is connected to an AC circuit, current appears to flow through the capacitor. So, AC circuit, current appears to flow. Current appears to flow through a capacitor because of the continuous increase and decrease of voltage and because of the continuous change of polarity in a circuit. So it's changing, or appears to flow, because of the change in voltage and polarity. Okay? The current flow in a pure capacitive circuit is limited by capacitive reactance. So, current flow limited by capacitive reactance. And we remember that is X sub C, right? Capacitive reactance is measured in ohms. So, it's measured in ohms. In a pure capacitive circuit, the circuit leads the applied voltage by 90 degrees. There is no true power in a pure capacitive circuit, so there's no watts. No power, aka watts, in a pure capacitive circuit. Capacitive power is reactive and is measured in VARs, as is inductance. So, measured in VARs. Capacitive and inductive VARs are 180 degrees out of phase with each other. Alright, and we remember, just to refresh your memory, the formula, which we know where the formulas are in this book, but the formula for capacitive reactance is 1 over 2 pi frequency C. And capacitance is 1 over 2 pi frequency X sub C. Capacitive reactance is measured in ohms, remember that. So once you find your capacitive reactance, you can use that as your resistance and just use Ohm's law to figure out voltage or current in a circuit.